In these next few videos, we're going to be learning about factors and multiples. There's lots of vocabulary here, so make sure you practice using the Quizlet sets that are available to you. First, we're going to start with the definition of a factor. Basically, it's just when you take a larger term and you break it down into smaller things that multiply to that term. So for example, for the number 30, I could do 1 times 30. Or I could do 2 times 15. Or 3 times 10. Or 4 doesn't work. If I were to do 30 divided by 4, I'd get a decimal, so 4 won't be on my list. Or I could do 5 times 6. So all of these integer values that multiply to 30 are the list of factors of 30. Now some numbers are prime, some are composite, and some are neither. So an example of a number that would be neither would be the number 1. But a prime number has exactly 2 factors, the number 1 and itself. So for example, 5 is prime because you can't break 5 down into smaller factors that multiply to get 5 other than just 1 and 5. And then composite numbers, for example 30 that we just did a moment ago, 30 would be composite because there were lots of numbers on that list, 1, 2, 3, 5, 6, 10, 15, 30. So more numbers than just 1 and 30. So here in our chart, we're going to list a few examples here and then determine whether they're prime or composite. So for the number 24, I could do 1 times 24, or 2 times 12, or 3 times 8, or 4 times 6. But because there are numbers other than just 1 and 24, that means that 24 is composite. For 41, I could do 1 times 41. 2 wouldn't work because if I did 41 divided by 2, I'd get a decimal value, and I'm just looking for integer values. The same thing is true for 3, 4, 5, 6. If I keep counting off and trying all of those integers, none of those are going to work. And it turns out that 41 is prime because the only numbers that I can multiply together and get 41 are 1 and 41. Again, I'm restricting myself to just the integer values, so no decimals. For 51, I could do 1 times 51. 2 doesn't work. If I do 51 divided by 2, I'd get a decimal. I could do 3 times 17. And again, I could keep checking. 51 divided by 4 gives me a decimal. 51 divided by 5 gives me a decimal. And I'd keep checking all the way up through 17, which is already on my list, and I won't find any more. And even though there's only 4, 1, 3, 17, and 5, that's still more than just 1 and itself, so it is composite. 89, I could do 1 times 89. And then again I'd check 2, 3, 4, 5, and none of these are going to work. They're going to give me decimals every time. I do 89 divided by 2, 89 divided by 3, 89 divided by 4. They're going to keep giving me decimals because 89 is prime. For 121, I could do 1 times 121. 2 doesn't work, 3 doesn't work, 4 doesn't work. If I do 121 divided by each of those, I'll get decimal values. But 11 works. 11 times 11 is 121. Now I'm only going to put that number on the list once. I won't write 11 on the list twice. But still, it is a third number other than just 1 and itself. So 121 is composite.